Good morning. Good morning to everyone. Fine. So we will start with the revision, means whatever we have done in the last class. Alright? Now when it comes to last class, can anyone tell me what and all we have discussed? It was majorly about the reactions, right? So we have discussed majorly about the reactions. Now in that case, which and all those reactions which we have discussed in the last class? That is potassium permanganate, which is showing the oxidizing property with some example we have discussed. So where if I take permanganate ion, if I treat with the iodide, what is that product I am going to get in? Under acidic condition. First we will talk about acidic condition. No, only major product we will talk about only. It is iodine molecule. Iodide will become iodine molecule. And this will become Mn plus 2. Yeah, even that one will. Mn plus 2. Now, same thing, which is that another reagent which we have discussed. Which is that another reagent which we have discussed. So that is sulfide, right? So hydrogen sulfide, which will become sulfur plus Mn plus 2. Sulfur plus Mn plus 2. Then what else we have discussed? First,
Kc
we have discussed.
Kc
KCl. KCl. No, we have not discussed about KCl. Anything else? Then we have discussed about KNO2, potassium nitrate, right? So which will become nitrate plus Mn plus 2. Then what else we have discussed? And we have gone with the ionic equation, no doubt. What else we have discussed? Fast. Okay, very good, Purnima. So we have discussed about sulfurous acid or sulfite, right? What will happen to this? It will become sulfate plus Mn plus 2. Plus Mn plus 2. Anything else we have discussed? Okay, fine. So these are some of the reactions which we have discussed in the last class. Anything left? We have left anything? Okay. Ferrous sulfate. We have discussed about ferrous sulfate, that is Fe plus 2. Fe plus 2, which will become Fe plus 3 plus Mn plus 2. So these are the reactions which we have discussed, right? Now what I mean to tell here is a pink color solution will become brownish color. Then there will be formation of precipitate of sulfur because it is insoluble. Now there will be formation of nitrate. Now there will be formation of yellowish color Fe plus 3. Now there will be formation of sulfate. So common product here is Mn plus 2. That means under acidic condition, permanganate, that is Mn, manganese, plus 7, it is becoming plus 2. This is with respect to acidic condition. Right? Now in basic condition, we were talking about basic condition. So what will happen to the manganese under basic condition? Anyone? What will happen to the manganese? It will become MnO2 under basic condition or neutral condition. So that's where we have the changing the oxidation state of manganese. Yes, Narsimha, you are right. So it will become manganese dioxide. Now, in the last class, we were solving one particular equation where I did the mistake in the beginning itself. Even you people have not noted that. Anyway, we are going to do that one properly. It was actually a simple equation. So that's where we have the MnO4 minus. I was talking about thiosulfate, right? So conversion of thiosulfate to sulfate, right? So conversion of thiosulfate to sulfate under basic condition. So what is meant by thiosulfate? S2O3 minus 2. So normally in the laboratory it will be supplied as sodium thiosulfate, that is Na2S2O3, because minus 2. So to neutralize that one, 2 sodium ions are required. Then we have basic condition, right? So water, it will get converted into sulfate, SO4 minus 2. Thiosulfate, S2O3 minus 2. So this is thiosulfate ion, which will get converted into sulfate. What should be another product? Another product will be manganese dioxide. What will be the another one? That is hydroxyl ion, because to balance the hydrogen. Right? So until unless we have water and OH minus, we cannot balance these equations. Fine. Now, when we come to the balancing the equation, we have MnO4 minus, which is getting converted into MnO2. Now, plus 7 here and plus 4 over here. That means permanganate should accept 3 electrons. Permanganate should accept 3 electrons. Then only it will become plus 4, or it will attain plus 4 oxidation state. Now, S2O3 minus 2. Oxidation state of sulfur here is, we have calculated in the last class, that is plus 2, which is getting converted into SO4 minus 2, where it is having plus 6. That means here it has to lose the electron. How many electron? It's actually 4 electron. It's actually 4 electron by the each sulfur. Please remember, that's where we did the mistake. I wrote directly as 4 electron, but actually how many sulfurs are there? So 2 sulfate ion has to be formed. Each sulfur from plus 2 to it will becoming plus 6. So therefore 4 plus 4, that should be total 8 electron, not 4. That's where I did the mistake, and even if people didn't inform me that, so it should be 8 electron, because I had written 2 sulfate only. But while writing the electron, I wrote it as 4 electron, right? See, that's where we will do the mistake. Okay? Now cross multiply to make the number of electrons equal. So cross multiplied by 8, cross multiplied by 3. Now we have 8 MnO4 minus, then 8 MnO2, then we have 3 thiosulfate, and here it will become 3 2s are 6. So that's where we are going to get the 6 sulfate ion. Now we should balance the oxygen and hydrogen. Now on the left hand side, how many oxygens are there? 32 plus 9. Right? So that means 41. We have the 41, okay, 42, even water is there. So 42 oxygen. Now here, so 24, 16 and 1. Okay, here we have the 41. So here it is 42, there it is 41. So less oxygen is here, so I will make it as 2OH minus. Now I think oxygen got balanced. Even hydrogen is balanced. That's where we have the equation. So one mistake was made me to spend so much time in balancing the equation. Which is that mistake? That was I took it as 4 electron. While telling I told 2 sulfate should be formed because 2 sulfur is there. But while writing I wrote it as 4 electrons. So that's where we were not able to balance the equation. Fine. So this is what the equation is, where thiosulfate will get converted into sulfate. Okay. So any doubt? Fine. So that's where we have the reaction. This thiosulfate and all you will come across when you go for the higher studies, where this thiosulfate will be one of the common reagent for the titration purpose. Okay, so that's where you will come across these reagents, especially with iodine estimation and all. They will be using thiosulfate, sodium thiosulfate. Fine. Any doubts? Now when it comes to one of the important point in application, why I am mentioning this one? Because in your practical viva it will be there. We have one of the reaction which is called as Bayer's reaction, or we have the Bayer's reagent. Bayer's reagent means alkaline KMnO4. It is nothing but alkaline KMnO4. So what will happen here is, what do you mean by alkaline? So that means basic condition. So KMnO4 will be maintained under basic condition. That's where we have the alkaline KMnO4. So what is the application? This will be applied to find the unsaturation in a hydrocarbon. Unsaturation in a hydrocarbon. Got my point? Now what will happen? Whatever permanganate is there, MnO4 minus, in the presence of unsaturation, it will get converted into MnO2, then MnO4 minus 2, that is permanganate, means manganate. This is permanganate, that is manganate. Minus 1, minus 2. Anyway, reaction they will not ask. They will ask the principle of Bayer test. So that's what it will happen, and there will be addition of oxygen across the double bond. There will be addition of oxygen across the double bond. That's what it will happen. So due to that, what will happen? As the number of unsaturation is there, pink color of the solution will become colorless, or it will become less color, which is called as discharge of pink color. That's what you will find out in your NCERT practical book. Okay, so that's what you should tell. Principle of Bayer's test or Bayer's reagent. What is Bayer's reagent? Bayer's reagent is nothing but alkaline KMnO4. So what is the application of this particular reagent? It is used to identify the unsaturation. For example, I have oil. I want to know how many unsaturated fatty acids are present in those oil. Then I will go for Bayer's test. It is having huge application. Like that, permanganate is having huge application in the laboratory where it will be used as a oxidizing agent. So here also it is acting as a oxidizing agent where there is addition of oxygen across the double bond. Fine? All of you have understood? Any doubt? Okay? So now today we are going to start with the F block element. Today we are going to start with the F block elements. Okay? So any doubts in D block elements? Okay? So please remember preparation of KMnO4 dichromate. Many times they have asked for 2 to 3 marks. You have to practice. Now we will come to F block elements. Now when I am talking about F block element, why they are called as F block elements? We have discussed S block, we have discussed P block, then we have discussed D block. Now we are entering into the last part in the periodic table, that is F block. So why they should be called as F block? That is because in these elements, or these are the elements, these are the elements where or in which F subshell will be getting filling up. F subshell is getting filling up. Okay, so that's what we can tell. So that's why these elements are called as F block elements. Someone has written. So valence electrons in F orbital. So instead of that we can call it as F subshell. Valence electron means outermost electron. But when I am talking about these elements, F subshell is not the outermost shell. We have many other shells. Okay? So it will be anti-penultimate shell. F subshell will be anti-penultimate shell. But anyway, we can tell that one. But or we can tell here that these are the elements where F subshell is getting filling to avoid the confusion. All of you have understood? So that's where we have the F block element. Now, if you observe your periodic table, so where they have given periodic table like this. Okay? Now, at the bottom they have given once again 2 series. Right? So that's where we have the F block element which is present at the bottom. That is because why they have given separate place for the F block. The reason is very simple, to maintain the shape of the periodic table, to avoid the confusion. Otherwise what will happen? In the D block, within the D block, as I have told while discussing about the D block, within the D block, especially about the 5D and 6D series. So that's where within that series F subshell, that means F block will come. So if they not include this one here at the bottom, then the periodic table would have been, like this. If they are not mentioning at the bottom. One thing is here, and another important point here is D block element would have been like this. This is where we have the D block. So this will become F block, this will become D block, this will be P block, this will be S block. Too much confusion, right? Because some of the P block will be pushed to that side. So to avoid those confusion, they have kept F block at the bottom of the periodic table. All of you have understood? So that's where we have the F block element, which will be shown at the bottom of the periodic table. Now you should tell me from which period F block element should come, or in which period F block element should come.
Period, sir. Sixth period.
sixth period. No, this one not. In which particular block F block will be coming? Which period? Okay, Purnimashi has written sixth period. Fine, only in sixth period. Okay, Manvit has written 4F. Fine.
Fourth period.
Okay, so we will go with Aufbau principle. 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F, 5S, 5P, 5D, 5F, 6S, 6P, 6D, 6F, 7S, 7P, 7D, 7F. Okay, fine. Now if I observe from energy level 4, F subshell is available. From energy level 4, F subshell is available. Right? But whether exactly from period 4 we are going to have the F block, that's what we have to see. When I am filling up the electron, 1s will get filled up, then comes the 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, then 4d, 5p, 6s, then comes the 4f, then comes the 5f, right? So what I mean to tell here is, until unless I entering into the sixth energy level, until unless I am entering into sixth energy level, Manvit, you are talking about the series, like 3D series, 4D series we have discussed. Same thing you have written 4F series, 5F series. But my question here is, from which particular period F block element will be there, or in which period F block element will be there in a periodic table. So according to that, if I observe, after 6s is getting filling up, then only 4f is going to start filling up. Then only 4f is going to start getting filling up. So what I mean to tell here is, if I go with the D block, after 5 years 4D, that means n minus 1 I can tell for D. N minus 1 I can tell. When n value is 5, when period number 5 is there, now I am going to have the 4D. If I have the period number 4, then I have the 3D, that means n minus 1. Now when it comes to F, it will be when 6s is there, when period number 6 is there, I am talking about 4f, that means n minus 2 is applicable for F. N minus 2 is applicable for F, Manvit, absolutely correct. So that's what we can observe, right? So that's what we can observe. That means, although there is the availability of the F subshell at the fourth energy level, but until unless the element is going to have the 6s getting filling up, then only 4f will come into the picture. That's what Aufbau principle talks about. And that's how electrons will exactly move to that respective energy level. So that means from period number 6, then only we can have the F block element. So period number 6, that is 4F series. Period number 7, that is 5F series. Got my point? So therefore F block elements will start from period 6 and period 7. So last two period, which has been shown at the bottom of the periodic table. Now period 6 will be called as 4F series. It will be called as 4F series. And period number 7, it will be 5F series. I am not talking about the whole element present in period 6. No. I am not talking about that one. Don't get confused. First two, it will be period number 6, it will be S block. At the last, it will be P block. In between, we have the D block also. But what I mean to tell you is, I am focusing on F block. So because I am talking about only F block here. But that doesn't mean that the whole element in period 6 is 4F series. No, I am not going to tell that one. Please remember, among the 32 element in period number 6, right? So there will be these elements which will be present. Okay? 32 plus 14. This is 14 elements. Fine? So that's where we have the period 6 and period 7. Any doubt in this? We don't have F block element in period number 5, period number 4 and all. We cannot have the F block elements. Only at period 6 and period 7 at present we have the F block element because we don't have period 8. Okay? So any doubt? So that means we have only 4F series, 5F series F block elements. Any doubt? Now, if I observe it here, if I go with 4F series, this is the element 1, 2, 3, 4, 5 and 6. That means N is equal to 6 for the outermost shell. N is equal to 6 for the outermost shell. Now if I observe, after 6S, then comes the 5D, 4F and 5D. That means when I am talking about N is equal to 5, that's where D starts. When I am talking about N is equal to 4, then comes the F. Got my point? So that's what I mean to tell. N minus 1D, N minus 2F. Where N is nothing but principal quantum number for the outermost energy level. Okay? So by considering that, that's what we can observe here. That means this one, I will call it as penultimate shell. This one I will call it as penultimate shell. This is outermost shell. And next to that one means inner side. That is called as penultimate. Last but one. That's what we can tell. Penultimate stands for. Okay? So now, this is called as anti-penultimate shell. That means anti-penultimate shell means that's where it is last but two. Okay, last but two. From outermost, if you move inside at third energy level, it is called as anti-penultimate shell. So that's where we have the terminologies. Okay, so due to that, anyone, can you tell me D block elements can also be called as D block elements can also be called as, can anyone? Because already we have done with this particular class about the D block element. Can any one of you tell me D block elements can also be called as? Wow. Anyone, fast. One word I want, that's all. Okay, I will give a hint. Based on the position. Okay, very good. You people have given the answer. Very good. One is Brazu and another one is Purnima. Okay. Yes, it is called as transition elements, right? So D block elements, they are called as transition elements. Why they are called as transition elements? Because of their position in the periodic table. They are exactly between the S block and P block element. So due to that, they are called as transition element. Now, since here anti-penultimate shell is going to get filling up, so therefore they are called as inner transition elements. They are called as inner transition elements. F block element or inner transition elements. D block elements or transition elements. Why that word inner comes here? Because here ant penultimate shell is going to get filling up. So therefore they are called as inner transition element. But otherwise their position is exactly between the S block and P block only. Please remember, although they have shown at the bottom of the periodic table, if you go with exactly their atomic number, they will be in between the D block itself. That means their position is between S block and P block elements only. That's what I told in the beginning itself. So therefore they are called as transition element, no doubt. But another word will be included, that is inner transition elements. Any doubts in this? Any doubt? Anyway, don't worry, I will give a brief about all these things, whatever I have told. But any doubt, whatever I have explained? So there are two series, 4F series and 5F series. All together they are called as inner transition elements. Okay? Inner transition elements. Now, 4F series, it is also called as lanthanide. Lanthanide series or lanthanides. Okay? So same way, here it is called as actinides. Here it is called as actinides. Fine? So that is because what are lanthanides? So these are the 4F series elements. Yes, Manvit, actinides. So why they are called as lanthanides and actinides? That is because these are the 4F series elements. 4F series elements after the lanthanum. After the lanthanum. Lanthanum actually belongs to D block. But after lanthanum, 14 elements, they comes under 4F series. Therefore, they are called as, those elements are called as lanthanides. Why I am telling 14 elements? 14 elements means all of us we know that F subshell is having 14 orbitals. So therefore, it will be having 14 elements. Like P block, 6 groups. Same way we have 6 elements in each period in P block. D block, it will be 10 elements in each period. Right? So that means 10 groups will be there in D block. S block, it will be 2 groups and each period will be having 2 elements. Same way here it will be 14 groups, but actually there is no exactly group for F block, and it will be having 14 elements in each period. So 4F will have 14 elements, 5F will have the 14 elements. Fine? So 4F series are also called as lanthanides. Why they are called as lanthanides? Because they start after the lanthanum. Okay? Now, same logic is applicable for actinides. Why they are called as actinides? Because these are the elements. These are the elements. Here instead of 4F, I should write it as 5F series elements. 5F series elements. These are the 5F series elements which are present after the actinium. Which are present after the actinium. So that's where we have the elements. Okay? So lanthanides and actinides. So these are the two F block elements. Lanthanides, 4F series, actinides, 5F series. Any doubt? Okay? So actinide means it is 4F series. Lanthanides means it is 5F series. Okay? So if you don't have any doubt, shall we move to the next one? So now I will talk only about the lanthanides first. If you don't have any doubt in this, I'll start with the lanthanides. Okay? Fine. Now I will be focusing on 4F series or lanthanides in F block only. Okay, na? So 4F series or lanthanides. Okay. In that case, before going for that, as usual, first we will write the inert gas: helium, neon, argon, krypton, xenon, and radon. To write the electronic configuration, that's all. So helium, it will be 2 atomic number. Here it will be 10. So here it will be 18. Here it will be 36. Now 36 plus 18, how much it will be? 54. Then 32, that means 86. So that's where we have the inert gas. And that's where we have the of-pore diagram also. Okay? Now when it comes to 4F series, always it will start from cerium. Always it starts from cerium, which comes after the lanthanum. Okay? So atomic number here it is 58. Atomic number here it is 58. And it will go up to lutetium. It will go up to lutetium. That is Lu. What should be the atomic number for lutetium? Any one of you? Cerium is 58. What should be the atomic number of lutetium?
71.
Okay. One answer is coming as 71. All of you will agree? All of you will agree with this? 71 as the answer. Atomic number of lutetium. Yes, it should be 71 because cerium itself is one of the F block element. No, Purnima, it should not be 72. What you have done the mistake here is you have simply added 40 into this. That's why you are getting 72. But you should not add 40 into 58 because 58 is itself one of the element which belongs to 4F series. So other than that it will be 13 elements. Sorry, other than that it should be 13 elements. So therefore it should be 71 because cerium itself is one of the F block element. Got my point? Now after that, if I go with anyway, we are talking about 4F series, I will not talk about 5F. We will not mix it up. Okay, that's where we have the 4F series elements. Can any one of you write the electronic configuration for cerium? Now can any one of you write the electronic configuration for cerium? So we have to take the help of xenon. Since it is fifth period, 1, 2, 3, 4, 5, fifth period. Since we are in sixth period, we have to take the help of fifth period. So that's where xenon, all the elements of lanthanides, electronic configuration should go with xenon as the inert gas. Okay? So xenon belongs to fifth period. That means up to 5p. Okay, 4f1, 5d1, 6s2. Okay, fine. So for 5p we are done. Then we have to go with 6s, 4f and 5d. 6s, 4f and 5d. Up to 5p we have written. Okay. So in that case, can you tell me what is the leftover one? Leftover will be 58 minus 54. So it will be 4 electrons which are left over. So that means if I go with arrangement from lower to higher range, anything you can write, then I will write it as 4f, 5d, 6s. Reverse also you can write. No problem. No one can make it as a wrong one. If that is also fine. This is much more fine because higher number I am showing it outside. Okay. So in that case, it can be written as 6s. First it's going to get filling up. So I will make it as 2. Then 4f will come. So I will make it as 2. Where is the option for 5d? Some of you have written for 5d. No option for 5d. No electrons left over. So it will be 4f2, 6s2, 5d0, or no need to show the 5d. But why we are showing 5d? Because 6s4f is there. So therefore, to maintain the number, we can show it as 5d0. So this will be the electronic configuration for cerium. This will be the electronic configuration for cerium. Now, we will come to lutetium.
So why can't it be 4f1, 5d1?
That is because, see here, after 4f getting filling up, then only 5d will come, according to Bohr principle. 5d, there will be entry of electron, don't worry. There will be entry of 1 electron. So that is possible only when the stability it will be there. Otherwise they will not go for this filling of 5d. I will come to that. Okay. Now if you observe the lutetium, can any one of you write electronic configuration for lutetium? Yeah, lutetium. Can any one of you write the electronic configuration? It's there, no? Electronic configuration. Yeah, it is there. Yeah, it is there. Electronic configuration is there.
So what is the electronic configuration of lanthanum?
That is 57, where 5d1, d subshell is getting filling up, lanthanum. Okay? So therefore it belongs to D block. Therefore it belongs to D block. We are not including lanthanum here because it comes in D block due to that reason.
For that, why doesn't it get filled in 4f?
That is because energy level. Difference is less between 5D. Okay. So Mayank question here is, what is the electronic configuration for lanthanum? When it comes to lanthanum, it will become 5D1. 4f, no electron, it will become 5d1, right? So that is because when I am talking about 4f and 5d, very less difference in their energy level. So element, what they will do is, whichever stable electronic configuration is there, it will go for that. Okay? So but when it comes to cerium, it will enter into the 4f. It will enter into the 4f. So therefore it has been included in F block, and therefore lanthanum has been included in D block because that D subshell is getting filling up. Here F subshell is getting filling up. Fine? All of you have understood? So that's where we have now lutetium. Any one of you? Lutetium. Okay, 5D1, 6S2. Kirtana, how it's possible? How you can forget 4F? So that's where xenon. Yes, we have to take the help of xenon. So 71 minus 54, right? So that means 7. So here it will be 17 electron. We have to fill it up. So up to 5p we have done. Now we have to show it for 4f, 5d, 6s. Right? So total 17 electron we have to fill it up. Can anyone fast? She has forgotten to fill the 4f itself. Fast. 17 electron we have to fill it up. You have written?
4F14, 5D1, 6S2.
5D1, 6S2. Absolutely correct. So that's where we have the lutetium. So 4F1, no Kirtana, 4F14. Okay, by urgency we have not written 14. So it will be 4F14, 5D1, 6S2. That means F sub shell got completely filled up. F sub shell is completely filled up. That's where we have the 4F40. That's where we have the 4F40. Can anyone tell me at which atomic number will have the 4F7? At which atomic number we can have the 4F7? Fast. That is also there. Yeah, it is there. At which atomic number it should be exactly 4F7? Manvit, very good. That is gadolinium. So we have the gadolinium. Don't worry, I will go with some elements only. So yes, at 64. So in that case, can someone write electronic configuration for gadolinium? Not 47 Kirtana. As Manvit has written, it should be 64. That is for gadolinium. Xenon 54. Here it is 64. 10 electron we have to fill it up. So that means 4F, 5D, 6S. If I go with that 6S2, then comes the 4F. In reality, it should have been 10 now. That means 8. It should have been 8. That's what I told. Now here, to attain the stability, what it will do is, instead of making it as 4F8, so it will make it as 7. Why 7?
Half will.
Because half full. So 1 electron which will move to the 5D. 1 electron it will move to the 5D. So that's where there will be redistribution of electrons. So that's where we have the redistribution of electron. So therefore, please remember cerium, this is the electronic configuration, lutetium, this is the electronic configuration, and gadolinium, this is the electronic configuration. Now if that is the case,
So what about 63?
63, then it will go to the 4F8 and like this only it will fit. Or based on the ionic condition, it will change then. 63 it will not have 4F7. It will have regular this one only. But when it comes to 64, to attain the stability, it will become 4F7. 2-3 electrons, it cannot play like that.
But 63, it will have only 7, right? 9 electrons.
No, that's what. 63 can also have the 4F7, no problem. It can have. But 3-4 electron, if the difference is there, then it cannot do like that. And ionic form also, it will have the stable ionic form it wants to attain. Okay, my own question is, if it is 63, yes, since 2 electron difference is there also it will have the 4F7, no doubt, to attain the half-filled electronic configuration. Then D will enter with the electrons, or it will become 4F7, 6S2. D subshell, no electron, because it's 63. That many electrons are not there. It will not go to the 5D. Okay. So why I have written gadolinium? Because although there is an option for D to get electron, but still 4F will have the 4F7 and 1 electron it will shift it to D. Otherwise it should have been 4F8, 5D0. But to attain the stability in gadolinium, we can observe 1 electron in D subshell. If that is the case, by seeing these 3 electronic configuration, can any one of you tell me what will be the general electronic configuration for 4F series, that is lanthanides. What will be the general electronic configuration? First.
Xenon 4F0 to 14,
Okay.
5D0 to 1, 6S2.
Okay. All of you have understood this one, right? So if I go with 1 mark question, you can expect. So, general electronic configuration. Even for competitive exam, you can expect. General electronic configuration for lanthanides. So naturally it will be xenon, no doubt. Then it will be 4F. It will be 4F.
0 to 14.
Instead of 0, it will be 1 to 14. So it will be 1 to 14. Then 5D.
0 and 1. 0 to 1.
Yes, it will be 0 to 1. Then 6S. It will be 6S2. So that's where we have the general electronic configuration, where we can mention it as N minus 2 F 1 to 14, N minus 1 D 0 to 1, then NS2. If I make it as xenon here, then it's understood that I am talking about 4F series if I have written XE here. Okay? Otherwise, if I remove this one, it is the general electronic configuration for F block elements. Okay? So all of you have understood. So that's where we have the general electronic configuration for 4F series or lanthanides. Any doubts? Remember about this electronic configuration. It will help you out when I am talking about oxidation state. You should not forget about these electronic configuration. Only 3 I have written, and when it comes to 5F series, another 2, 3 I will write. That is more than enough with respect to understanding the electronic configuration. Any doubt in this? So in that case, what and all we have discussed in 4F series or F block? One word we have discussed here is, that is inner transition elements. We have discussed about inner transition elements. What do you mean by inner transition? That means we are talking about F block elements. Why they are called as inner transition? Because in those elements, anti-penultimate shell is going to get filling up. That is F sub shell is getting filling up. That's why they are called as inner transition. Now, we have discussed about 4F series, which are called as lanthanides, and 5F series, which are called as actinides. That's what we have discussed, right? 4F series lanthanides and 5F series actinides. Why 4F series are called as lanthanides? Because they are present after the lanthanum. But lanthanum does not belong to 4F series. It belongs to D block. So 5F series, since they are present after the actinium, so therefore they are called as actinides. But actinium does not belong to transition. That means it does not belong to inner transition or F block element. It belongs to D block. Okay? So that's where we have the lanthanides and actinides. Then we have discussed about electronic configuration. General electronic configuration for 4F series is 4F 1 to 14. That's where 4F series. Right? Then comes the 5D 0 to 1. Then comes the 6S2. So therefore, since highest energy level is 6, so it belongs to period number 6 in the periodic table. Right? So all of you have understood? Any doubt? Anyway, here I will stop. Tomorrow I think we can finish it off. We have left over with actinides. Okay? So not much in detail is there for you people, F block element. like that of B block. Any doubt? Okay. So anyway, I will stop here. But once again, attendance is less. So don't feel bad. I can see the count. That's why I am telling. Earlier it used to be somewhere around 19, 20 and all. Not very much attendance used to be there. But still. But now it's got reduced. So try to come for the live class. If it is too much this one, then fine. We can go with the recorded one. But day to day this one you have to do. Okay? So don't take the excuse of COVID. That should not be the excuse. Okay? Thank you. Thank you very much. Take care. Okay.